So denial of service attack. We call it, the main way now is a distributed denial of service. Just a basic denial of service is going to be making your computer unavailable. And here's an old school one. Old school. We had one that was called the ping of death. Okay? And we've talked about malformed stuff, right? They just put the wrong, I'll just say malformed. They put the wrong data in the ping, and it would crash your computer. And everyone was using basically the same ping code, and so it worked on anybody's computer on the internet. There's even a better one, and I'm not going to get this one. There used to be a modem commands. I don't remember the exact command we used to do. You guys know I used to be a punk kid, right? You would send this command. It was an AT command. I don't remember what it was. And it would disconnect whoever's modem. And it was awesome because you could just be like chatting with someone and you would just type this command out and then they would be disconnected. That's a really punk one. So anyway, these are denial of service. Like to just crash the computer is the old way. The new way is distributed. And what we want to do here is, here we are, we got the internet. So we remember from our internet thing that, our computer is going to go over a few hops to get on the main internet. Oops, I'm not hopping them right. So if we remember when we did the trace route, there's all these networks connected in, right? And eventually, oops, I guess that's one of the computers. Eventually you get to, these computers that are connected to it. And then there might be other people over here. So there's lots of people spread around the internet, and we're all excited. And these are all zombies, okay? So there are zombies all over. Okay? Because this person put this code out on the web servers, and they got people, all across the United States, all across the world, and now their computer is infected. And what I want to do is, this is my target. They'll be red. Okay, so the target's here, and we might have the bad guy is just somewhere around on his computer or her computer. And what they're going to do is they will send out a command that all of these computers at once are going to send packets as fast as they can to the target. Okay? So the bottom line here is there are so many messages. The server or the network link is overloaded. Okay? So if I have enough people in my zombie network, they're going to overload my computer. The bad guy has to be in command, because what he wants to do is extortion. Have you ever seen in the movies when they have like the bad mafia guys come into someone's store and they start like knocking stuff over, and they knock stuff off the thing, and then they go to the, they kind of trash the place a little bit, and then they go to the store owner and they say, look, we sell protection from, we'd hate to see your store get messed up, or robbed or just trashed, so we sell protection from these sort of things. So if I'm a bad guy, I'm going to sell you protection from a denial of service attack. Isn't that a nice idea? So I might go, I'm the bad guy, I'm going to attack you for a couple hours, and then it'll stop, and then I'll call you up and I'll say, hey, I understand you run an important website and you'd like to keep it running. I think you just had a denial of service attack. You know, I can prevent those kinds of things from happening. And, you know, it's sad to say, but there's been people with enough zombies out there that the target just had no choice. You either pay or you go out of business. There was one just a little while ago. It was a company that was in Israel that was doing anti-spam. And their scheme was, if you got a spam message, you would send them the link that was in the spam. So if I got a link that said, like, pharmacy, come to my pharmacy. So I would send them the link that was in that email to the pharmacy website. And then their computer had this list of all these websites, and all their clients, it was kind of cute, would then request from the pharmacy that website stuff. So it was almost like a denial of service attack against the spammers. That's a great idea, right? But sadly, all these spammers have these zombie networks, right? And so one day the spammers said, hey, look, you need to stop attacking our pharmacy store. And the Israeli company is like, no, we aren't going to do it because we're the crusaders against spam. And the bad guys are like, okay, well, we'll talk to you in a week. And they flipped on the denial of service attack, and the Israeli company is no longer in business because they were out. There was so much traffic there, nothing could get in, nothing could get out. They were just done. They had a recent incident that was the same way, and I will show you that one. This one was kind of cool. So how do you fight it? There's really only one way right now that works. So remember, we normally have our target in one place. And then we have all the zombies out on the internet that are going to attack. Sorry, I'm going to make this really smaller. That's okay. You guys can deal with it. All right, let's put another one here. And we can put another network and another guy out here. Okay? So what happens, remember, is all this traffic gets concentrated, for example, on that one link. And they just had the same exact thing happen to a company called Spam House. It's a European company, and what they were is the people that keep that blacklist that says whose computers are relaying spam. This is where you got that list from. And so the spammers are like, look, let's take this guy out. And so they attacked him. This is only earlier this year. They totally attacked him and they took it out. So what these guys did, though, is we've gotten a little bit more sophisticated. And there are companies now that in the routing protocols can actually add in different versions of you that are all over the internet. Okay? So these would be almost like a shadow copies of, and if it's your website, I'm going to put Spam House, but it might be you too. And so what happens is in the actual routing tables, when these computers look up who they're supposed to attack, instead of going to the main place, they go to their local one. Let's see, then they'll go here. So they might go to the real one, but maybe these go here. You'll see where that would happen here. Okay. And that means, what?
It's like a decoy.
Yeah, they're like decoys. They're not really decoys, though, because they really have... They still have all the information you need on them. So these then spread out the traffic and So no link is overwhelmed. We still need to keep this link up because this one needs to duplicate out to these other things. But this company, and it's a good company, they have a certain IP range and they have deals with all the backbone router people that they're, you can look up an IP address and it doesn't just go to, on the DNS, to a different IP address. It's literally that IP address of Spamhaus goes to a different place on the internet. That is totally cool. So these guys stayed on.
So you're saying all the red ones would have the same IP address as the...
Yeah, this is the same IP address. So here we need to note it is the same IP. You got to pay for this. This fighting mode costs you a lot of money. But I think it really was successful here, and of course now we just have to see what these guys do to fight that. But so it's a company that provides this service. And so Spamhaus switches their DNS to this red company's network, their subnet. And the red company has a deal with these internet providers that when the routing table lookups for their subnet, it always goes to these local places. So a close by place. The company is set up just to do that. So Spamhaus contracts with this company, and that company made this stuff. It cost Spamhaus a lot of money, but it totally fought off denial of service attack. Oh, I don't think another company could do this on the side, because you have to be able to make a deal. Like whoever this ISP is, they have to say, this is a dedicated link. Anything on this subnet is going to go over here, not to where it really goes. So that's the idea there. What else was I going to say here? Oh, so just a couple of other ways. They've had different ways of doing denial of service. I'll just mention these because you keep seeing them coming up. In the old days, a distributed denial of a service attack was called a SYN flood. They would just have so many SYNs, it would overload the memory. Okay, so we've done SYNs, right, where you're trying to open connections. So they just do SYN after SYN after SYN after SYN. And in those days, you'd only need one or two computers. So you'd have a couple of 3 computers, and they would just send SYN, 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 and eventually the target just crashes because they run out of memory. Well, we can see that now. So the pattern there is obvious. Okay. Eventually, they moved to a ping flood. This is sort of the middle days. In a ping flood, it was lots of computers are going to ping the target. The problem with that was, with a really high bandwidth connection, a ping is relatively little data. Oops, relatively little data, right? So that was relatively little data. After a while, they would do things like web requests. Okay. But what happened here was you're limited by the upstream. This is really funny. Bandwidth. So you think about these computers here. So I'm trying to take out this target. Remember, a ping in the old days, the connection here would be so low that just pings from all these would have taken it out. As we upgraded these connections, a ping isn't enough. And so they would do a web request. And that has quite a bit more data in it. But now we're limited by, this is on the Cox network, and they can only send, so many ping requests at a time of so much data. And so now the client Like the bandwidth of this upstream connection isn't enough. And now we use reflection attacks. Okay, and they would do, first one, these were really awesome. One was that they would ACK with a spoofed source address. So this is kind of funny. I'll just show you on this paper. So here's how this one will work. Okay, I've got this client, remember, and they have relatively limited upstream bandwidth. Okay, but I might have, let's say I'm taking out the spam house, or trying to. Okay, so I want them to send, and I've already told you this, the direct route, I don't have enough bandwidth. But luckily, along the way, there's this other web server that's closer to the backbone that paid a lot of money. And for example, they might be CNN.com. We always pick on CNN, don't we? And so what I can do here is I can send, and this is wild, I send an ACK without a SYN. There's nothing to it. It's just an ACK. And I say it's from Spam House. So I use their IP address. And CNN is like, ACK? Why are you sending me ACK? And so they send back an error that goes to Spam House. There's probably 2 times to 10 times the upstream bandwidth on one of these servers, right? So I can send a relatively little amount of data in that ACK, and then the error comes back and it's a huge amount of data. All the rest of them is just hackers finding new ways of getting more data reflected back. DNS is a good one. They can send a DNS message or DNS request to a DNS server and ask for the whole contents of their table. We'll just put the database. So they'll ask for the whole contents of the database, and you were getting here, I think it was up to 100 times the amount of data. Okay, and so we're on, again, one of these high bandwidth connections. That's where a DNS server is. We're sending it like Spam House wanted this when they really didn't, but the server doesn't care. It just sends it along. That was a good one. And then the last one they just did, you guys have automatic time set on your computer. That's called the network time protocol. This is the sort of state of the art right now. I don't remember what they're sending, but they request some sort of time data, and they get a huge reflection. I should look this up, but this just barely, some hacker just barely figured this out. And so the latest denial of service attacks use this network time protocol reflection. That is so awesome. You guys ready to fight against denial of service? And the way you fight against it is the same way, right? Where did my thing go? It's trying to spread stuff around. This costs. I think, yeah, like I said, this was so effective. I think there will be more companies that do this. And so I think the cost will come down of it. Hopefully it'll work okay. But when someone calls you and says,
I was wondering if that company, Pacific Red Guys or ABC, can they do it for Spam House, protect Spam House and protect...
oh yeah, they can protect lots of people. Because they have a whole subnet, right? That means, 200 or so IP addresses, and they can give an IP address to various people. This is the only one I've ever seen that's public. They sell the service, obviously, and so there's probably more people that are actually protected but don't say. You following me?
Advertise.
So if I was Microsoft and I was contracting with this company, I wouldn't advertise that
What is it called?
I'm doing. I don't
Is that
remember the
denial
name of the
service-
company.
well, would it
Sorry.
be called like denial of service protection or would it be
Yeah,
something like that?
something like that. Denial of service protection, sure. If you're ever in the market for it, right? Hopefully that doesn't happen to us. No, but your little scheme would probably prevent stuff like this. One of the things they tell people to do, speaking of denial of service, is they call it egress. Where's my reflection? You're supposed to do what's called egress filtering, and that is if a packet comes out of you, so remember it's source address. If a packet comes to your firewall with a source address that's not your subnet, you should block those. So we'll say this, be nice and they call it egress. Egress is leaving. You ever heard of ingress and egress? Okay. Fancy words. So again, here it would be, making sure they couldn't fake this other destination address or the source address.
So the egress filter is on our end, you're doing.
Yeah, so when I configure my firewall, I should make sure any packet coming out has a source address on my subnet, and that would make it so these spoofed things wouldn't happen. Everybody knows that that's the way you should do it. All right, seems like everybody should know that, but nobody does it. So
Because you don't care what's going on.
that's right. I don't care if my computer's killing you. I just want your computers to stop getting me. All right, well, I'm going to stop there because I think we've done enough.